Last time we have started with homotheity, right? Okay. Okay. So till everybody join, let me give one problem on homotheity. Can you all hear me?
Yes, ma'am.
Yes, ma'am.
Okay. Because I have a circle. Okay, this problem originally was in Arthur Angel, and then uh, okay, sorry. Yes. So I have a circle, and okay, inside that two circles which are tangent circles to these. Okay, and a chord that is common tangent to both the circles. Okay. So what I have here is, suppose AB is a chord of a circle omega such that omega 1 and omega 2 are tangents to this at suppose points P and Q and R and S. Okay, followed, such that they are internally tangent to omega at P and R and tangent to this. So prove that PQ intersection RS belongs to omega. Belongs to omega. Okay. We have to prove that PQ intersection RS belongs to omega. Usually, how many students attend this lecture?
More
Miss,
than 20.
Around 20. Okay.
Miss, today I think there won't be students because in this FB batch they have started IHSOs on Mondays. So I don't think there will be more students today and after also if we keep on Mondays.
Why they have kept it on Monday then?
I exactly don't know that why I have they kept on Mondays.
Okay.
Yes, I requested them so much to keep on another day, but then too they kept it on Mondays.
Sorry. Sorry.
Ma'am, I requested them to keep on Thursday or some another day, but then too they are keeping on Mondays only.
I gave suggested Prashant sir an idea that he could keep it on Sunday evening.
Oh.
Sunday evening you don't have any lecture, no miss?
No, I don't have any lecture.
So he can keep on Sunday evening if it is possible.
मतलब Olympiad lecture?
Yeah, this Olympiad.
नहीं बेटा, Sunday evening नहीं. My all days are packed. I need at least one day free ना बेटा.
So Saturday morning wouldn't be possible na?
Saturday morning.
Ma'am, Saturday many people have school in the morning.
So, miss, so Monday will be free
IJSO
for you
lecture,
then.
but IJSO lecture they have started right now, na? So they should start with according to the Olympiad timetable is set from since when? Why they are changing my timetable?
I don't know. You can talk, miss,
Yeah,
to any of the coordinator.
I'll ask them. I'll ask.
Miss, Miss, I got a proof without using homotherapy.
Okay, that's good. That's good. No problem.
Angle chasing.
Angle chasing. Very good. Give me a while. Let everybody be comfortable. Then we'll discuss this.
Hello,
Yes.
teacher, are you explaining something or
No,
you have
I'm
given
not
this
explaining.
question?
I've given this problem. Okay. Are we all ready to discuss this?
Yes, miss.
Okay. So let me draw these lines. Okay. Now, let me draw only one line first. Okay. Let me draw only one line first. Okay. Now, suppose this meet here at T. So what I will do, first let me give the proof using homotheity and then we'll see the angle chasing proof also. Now what we'll do here is, okay, we will apply homotheity with center P that takes circle omega 1 to circle omega. Okay, followed. So clearly image of Q under this will be T, correct? And image of a, what will be image of chord AB? It will be tangent at T, correct? Image of chord AB will become a line which is tangent at T, correct? Is this clear to everybody?
Yes, miss.
Why it will become? Because it's a tangent, AB is tangent to this omega 1. So clearly the second line will be tangent to omega, correct? We know that these are parallel lines, correct? We know under homotheity every line will go to a parallel line. Therefore, if we join these, okay, what you will get? What you will get? This angle is same as this angle, okay, followed because of parallel lines. So what can I say about arc AT and arc BT? They are equal, okay. So that implies T is midpoint of arc AB, correct? Followed? Is this clear? Is this point clear to everybody? Any doubt, anybody?
No doubt, miss.
Therefore, T is midpoint of this arc means what? For any position of this circle, this line will meet here exactly at the midpoint. So in particular for this position also, okay, this line also will meet at the midpoint. Okay, followed?
Ma'am, arc AT is equal to arc BT because ATB is isosceles.
Because no, because this angle is same as this angle. So
Ma'am, but why would that be implied that the arc?
Acha, okay. Surya, see, and because angles up, this arc will be twice. Suppose this angle is theta, then arc BT will be angular measure will be 2 theta, and this tangent and secant this angle is theta. So angular measure of this arc is 2 theta, right?
Yes, ma'am.
Okay.
Okay.
Followed. So S point should be here. Okay. Huh? Followed? Is that clear to everybody? Any doubt, anybody? No. Now, who has got angle chasing proof?
Miss me.
Yes. Rachit? Yes, beta.
Miss, let O be the center of the bigger circle omega.
Okay.
Let O1 be the center of omega 1 and O2 be the center of omega 2.
Yes.
Miss, so O1Q, O1Q and O2S
Will be parallel.
will be parallel, and they will also parallel to the O2 the Miss, let D be the midpoint of AB, then OD will be parallel to O1Q and O2S.
D will be the midpoint of, no beta. If
Miss,
D
AB
is
is a,
midpoint of AB,
yes, Miss.
then it will be perpendicular, no?
Yes, Miss. Miss, and O1Q is also perpendicular.
O1Q, yeah. O1Q is also perpendicular. Just a minute, let me draw it properly. O1Q is also perpendicular, correct.
Miss, so Miss, join O1O and O2O.
Join O1O and O2O. Okay.
Miss, so let angle O1OD is equal to alpha,
Hmm.
and angle O,
O2OD.
yes, Miss, is equal to beta.
O2OD is equal to beta. Then this will be alpha
Yes, Miss.
and this will be beta. Then
Miss, and O1P are collinear.
O1 TR collinear, correct.
And similarly OO2R.
Yes, correct. Tangent,
Yes.
correct. Yes.
Miss, so angle OO1Q is equal to alpha, and so
O1Q.
yes, Miss. Miss, you have written alpha.
अच्छा हाँ O1Q. Sorry. Yeah.
Miss, so
So triangle is
as
2 alpha.
a triangle PO1Q is isosceles, so
Yeah,
angle
it is 2 alpha.
O1PQ will be alpha by 2.
Sorry, alpha by 2, not 2 alpha. Sorry, alpha by 2, correct.
Miss,
It
similarly
will be beta
angle,
by 2.
yes, Miss, beta by 2.
हाँ,
Miss, so now
हाँ,
if we join PR,
हाँ,
then we'll get that triangle OPR is also isosceles.
isosceles, correct.
And so angle OPR will be 90 minus alpha plus beta by 2.
Correct. हाँ. So this angle is 90 minus
Beta by 2, and
beta
this
by
is
2. Yeah.
90 minus
So
alpha by 2.
angle TPR is 90 minus beta by 2 and angle T T correct. TRP will be 90 minus alpha by 2.
Yes, Miss.
Therefore, angle PTR will be alpha plus beta by 2. Wonderful. Very good proof.
Yes,
Indeed,
this
very good.
is half of alpha plus beta.
Half of alpha plus beta,
Should
correct?
now in the
So
circle.
T point will lie on the circle. He has taken that. Let T be PQ intersection RS. Okay, and he has shown that it must lie on the circle. Very good proof. Rachit, really well done.
Ma'am,
Huh.
in your proof, could we instead apply homotherty on circle omega 2 through R?
Yeah, we can take the combinations of
No, yeah, and no, ma'am, do both in the proof, and then we can show that they coincide.
Yeah, of course. Of course.
So then, right, because
But
S
there
will go to
is
T.
no need, no? There is no need.
I mean, sorry, S will go to some point on the circle,
Yeah,
which will also be parallel to the
yeah,
secant
yeah,
AB, and then
yeah.
so it
That
must be
way
T.
also, yeah, correct. That way also you can do it. Okay. Now, the another version of this problem was asked in RMO just like few years ago, like 2 or 3 years ago. It is like this. May I erase this now? It was like this, that okay, better I clear and draw another figure. Okay, it was like this, that we have a circle, and then we have one circle here. And we have a chord, which is a common chord to these two circles. Okay. And then now this statement will be very, very obvious to you. Suppose I take this, okay, and from this point to here. Okay. Now, suppose this is what was it? PQ, and this is X, and this is RS, and this is Y. Okay. Followed. Then prove that XY is diameter. XY is the diameter of omega. So I call it omega 1, and I call it omega 2. Okay?
Done.
Yeah. Because just now we have proved previously that X is midpoint of arc AB and Y is midpoint of arc. Okay, let us call it a CB and a DB. Okay, arc ACB and this is midpoint of arc ADB. So obviously XY is diameter. Can you see that? Now, of course, this can be done by angle chasing also. Huh? Okay.
Ma'am, or the tangents of X and Y are parallel.
Tangent are X and Y are parallel. So it's a diameter. Okay. Followed? Is this clear to you? No. Oh, let me take the screenshot. Now there is one very cute problem on homothety. Have we done it last time? I don't remember. Okay. We have 3 circles, 3 congruent circles. Okay, 3 circles. Okay, 3 intersecting circles. Congruent circles that are intersecting. Okay, and their common tangents. Okay, Their common tangents. Okay. They form a triangle. Okay. Their common tangents form a triangle. Okay. Now, suppose they are tangent at, they are concurrent at three circles are congruent circles. Congruent circles have a common point P. Okay, and their direct common tangents make a triangle ABC. Okay, then prove that the circumcenter of ABC, in center of ABC, and P are collinear. Have we done this problems last time? Have we done this problem?
No.
No, ma'am.
Try this. These are congruent circles. Okay, three congruent circles have a common point P. Okay, so that everybody will talk in same language, let me label the centers. What we can label it? DF. Okay, we'll label it DF. Okay. Can it come in just 2 minutes? Yes. Is the board visible to you?
Ma'am, can you please zoom out a bit?
We can see only, yeah, now we can see the whole thing.
You can't see the text if I, okay.
Yes.
It's circumcenter of triangle ABC, then in center triangle ABC and P are collinear. This is you have to prove. Okay, now is it visible?
Yes, miss.
Yes, ma'am.
जरा आवाज कमी करा टीव्हीचा दार बंद केला तरी आतमध्ये आवाज येतो. Please tell me when you are ready for the solution. Yes. Shall we discuss this? Please respond.
Yes, miss.
Yes, ma'am.
Okay, how many of you got this? Or should I give you some hint?
Ma'am, hint, please.
Okay. So, Adish, what can I say about triangle DEF?
Similar to ABC.
Similar to
Similar
ABC.
to
That's it. How you got this similar to ABC? Because if I drop,
Ma'am, because all of them are parallel lines.
we have to prove they are parallel. If I drop,
Because you can draw rectangles.
yeah, if I drop perpendicular, they will form rectangle. Can you see that?
Yes.
So these lines are parallel, so we get similar triangles, correct? So sides are parallel, so these triangles are similar. So between any two similar triangle, we can apply homotheity,
Yes.
correct?
Yes.
Apply homotheity. Now here, what will be the center of homotheity?
P.
Let us see.
P.
What is always center of homotheity? Suppose I have 2 points A dash, this line intersection B dash will be always center of homotheity, correct? So not necessary that P will be the center of homotheity. Let us check what will be the center of homotheity. Center of homotheity, clearly A's image has to be D, okay? And B's image will be E, correct? Okay. So I need to extend my A.
Will it be in center?
Yes, it will be in center, correct? Can you see that? So it will be in center of which triangle?
Triangle DEF.
Both will have same incentive.
Yeah,
Both.
Both will have same in center because sides are parallel. So you can see that both of them have same in center. This is a hint.
Yes, ma'am.
Ma'am, we're guessing right now, or?
No, we are not guessing. I
Ma'am.
want to prove.
Ma'am, but translating it around and you could still get that
Ma'am, done.
with the same
Very good.
incentive.
That's it. So
You could still
homothetic.
have lines parallel without the same incentive. How
So
will you prove that they are the same incentive?
how will prove that they are same in center? Just a moment. I'll prove that. Homotheity at I, that text triangle ABC.
Actually, I did not understand how will I be the in center.
I will explain. I'll explain. See, pay attention because lines are parallel. Huh? Adish?
Yes, ma'am.
So half of A by 2 and these two are congruent.
Yes, ma'am.
These two are congruent.
Yes, ma'am.
So the angle bisectors of ABC are angle bisectors of DF. So they share
Okay,
common
ma'am.
in center.
Okay, ma'am.
Okay. Now using this, how will I prove they are concurrent, collinear? See, recollect that any point, its image and the center of homotheity are always collinear. Can we encash that? So in short, I need to show that circumcenter and P are collinear and in center is my center of homotheity, correct? So what I need to show?
Circumcenter of
image
DEF goes to circumcenter of ABC.
Sir,
Goes
that
to
is
P.
obvious. That is obvious. I need to show that
P's
circumcenter of
images.
ABC goes to P.
Yes.
P's image is a circumcenter.
Yes, correct. So we need to show that circumcenter of triangle ABC is nothing but P. So it is as good as to prove that P is the circumcenter of triangle DF. Can we prove that?
Yes, ma'am.
Why?
Ma'am, all three of them are congruent circles, so
Yeah, three of them are congruent circles. So D.
the radii is equal.
Yeah, radii are all equal.
Ma'am, do you have a worksheet of problems or?
Yeah. Worksheet of problems. Yeah. You want? Okay, I'll share it.
Yes, thank you.
Ma'am?
Same worksheet which I have shared last time. Huh?
Ma'am, for your common incentive proof, you're already assuming that D lies on AI. When you say that they have common incenter, you're assuming that D lies on AI.
D lies on?
AI.
Yeah, but D will lie on AI.
Yes, ma'am. So we need to prove that also, right?
You didn't understand. When I say that angle bisector of ABC, it's same as angle bisector of DF. Isn't it obvious that I lies?
Ma'am, but how can we need to show that they have the same angle bisectors? You are taking D on AI, right?
Just a moment. My argument started with consider a angle bisector of A. So here we started the argument like this. Consider angle bisector of A. Okay. Now because these lines are parallel, this angle will be congruent to this angle and this angle will be congruent to this angle. Right, Surya?
Ma'am, yes, ma'am, but how do we know that that angle specifically will form with D, that D lies on the angle bisector?
Assume I does not lie on AD.
D is in center. It is a point of congruency of three angle bisector. See, if I draw any tangent here, this is a circle touching at, okay. Let me show it this way. If you drop a perpendicular here.
Yes, ma'am. So we need to say that, right? I realize that.
Okay. We need to say that. Okay, I kind of assumed it. See,
Oh, okay, ma'am. Sorry.
sorry. I kind of
I'm
assumed
sorry. I
because
thought
it was like
we were not overlooking.
Circle touching two sides, then obviously the angle
It'll lie on. Okay.
center,
Like you can say by homotherty also.
center will lie on angle bisector, correct?
By homotherty, right? Or by equal distance.
Simply, yeah. That will be equidistant from two sides, no? Center will be equidistant from two
Right.
sides.
Yes.
Huh? Okay. See, if you take any third line here, tangent to this circle, beta, then D will act as the in-center of triangle A and that line formed by that. Okay?
Okay.
Okay. Is this clear to everybody? Any doubt, anybody? Page number 3. Okay.
Ma'am, I cannot find the worksheet on the group.
You're not finding the worksheet on the group, then I'll reshare it. 2 minutes. Give me 2 minutes. Is this clear?
Yes, miss.
Arkan, 2 minutes. I'm doing one very nice problem. Let me first give the figure of that problem and then,
No problem.
Okay, everybody is done with this. May I erase this?
Yes, miss.
Okay, now suppose I have a circle. And a line such that the line is tangent to the circle at some point, say whatever point, say T, and M be any point on the tangent line. Okay, followed. So I have a circle called omega and M, this is a tangent, and M be any point at this. Find the locus of all points P such that I can draw tangents from P to this circle, and let me shift my position M, because M is okay. Suppose my point M is here. M is a variable point here. Okay. And I will get locus of point A. Suppose let me take locus of point A such that for every given point M on line L, there exist points B and C on line L such that first one, omega is an incircle of triangle ABC, and second, M is midpoint of BC. Okay. Take 2 minutes to work on this problem, and then I'll everybody understood? See, what is given to me? Just a circle and a line and any point M. Then I have to figure out a point A such that ABC is a triangle with inside circle omega, and M will be midpoint of BC. So clearly, as M moves on L, followed as M moves on L, I will get A as some, A will varies, okay? So I want locus of all such points A. I want to know on which curve A will move.
We're taking M as fixed, right, to find the locus?
Yeah. Actually speaking, usually you call them as variable point. You don't call them fixed, but for particular position of O, we find a position of A and then we generalize.
Okay.
Okay. Okay, I would like to give a hint for this. Is it okay if I give hint?
No, miss. 2 minutes. Wait.
Okay.
Yes, ma'am.
Okay. Okay. Everybody has taken down the problem. Can I, Arkan wanted the worksheet. Can I share the worksheet? But then
Yes,
Yes, ma'am.
yes, miss.
screen will get this thing, huh? Short. This is senior group, no? Okay, the name of the worksheet has IIMOTC because this was prepared when I was teaching for IIMOTC in HBCSE. Okay. You tell me when you are ready for the solution or when you are ready for some hint, anything. Huh? Till then, I'm hunting for some more good questions for you.
Miss, can you give hint for the second point?
Yeah. Second point means, beta, this should be together. Both the conditions should be satisfied together. Okay. Okay.
Can you give some hint?
Yeah, I'm giving hint. Huh? Hint is, okay, hint is the in-center ex-center lemma. What my in-center ex-center lemma says that I have first I would like you people to prove in-center ex-center lemma. Anybody remember the lemma, Arkan?
Yes, miss.
Yes,
I
ma'am.
remember the proof also, miss, a little bit.
Acha, who is that?
Miss
Arkan or
Raghav.
Raghav? Huh?
Raghav, miss.
Raghav. Okay, you remember the proof also a little bit. Very good. What is the lemma?
Miss, in center and in X center is IA and I. So I and I respectively. So then we have that IA, B and I is 90. Achha.
Okay, suppose X touch point, in touch point is suppose D means this circle, in circle touches here and X circle omega A touches at point say E, then this line will bisect, correct? Okay, followed? Line IIA will bisect it. Huh? Followed?
Okay, okay, miss.
And what else? If you join, if you take the diameter through D, So this is a diameter through D. Then what? Then this point
is reflection of
yes, they are collinear.
yeah.
A, this point, suppose call it F. A, F and E are collinear. So try to prove this lemma. Using this lemma, then you can solve this.
प्रॉब्लम हो गया, लोकस मिल गया, अभी ये सिर्फ प्रूव करना है.
मिल गया ना वही I know. But I want you to prove this first. Okay, you can use homotherapy to prove this if you want. Yes.
From which you can also say that I, B, I, A, and C lie on the same circle, and so if the center, so midpoint of I and IA, and then the point at the midpoint of that you get lies on the circumcenter of ABC.
Circumcircle
of ABC, sorry.
Yes, correct, beta. Somebody's mic is on. Arya, I think your mic is on. Please check.
Yes, ma'am. Sorry.
It's okay because I know you must have not done it deliberately.
Yes, miss, done.
Okay, Raghav. Very good. Are we ready to discuss this?
Yes, ma'am.
Hmm?
Yeah.
Okay. Yes. Who will tell me? What construction I'll do? What I'll do is I'll apply homothety, okay, with center A that takes the X circle to in circle, okay. Under this, okay, the tangent, suppose I call this BC. BC is a tangent to X circle. Its image will be a tangent here, okay. B dash C dash, okay. So let B dash C dash be image of B, okay. So an image of EB, let image of EB F, okay. Followed? So now I need to prove that DF is a diameter. Because image of E is F, correct? Therefore, IF is perpendicular to B dash C dash. And we know ID is perpendicular to BC. Moreover, we know homothety takes a segment to its parallel line. So this implies that F, I and D must be collinear. Correct? Anybody else have different proof than this?
No, ma'am.
Okay, Raghav.
Yes, miss.
You did by same method?
Yes,
Or-
miss. Yes, miss. Same.
Okay. Okay. You can do it by angle chase also, but this is the shortest proof, I believe. Okay. Is this clear to you? Clearly, we can also show that if I extend this line AD by similar proof, if I take this, then image of DD dash is the other end of diameter. Okay, other end of the diameter is known as antipode. Okay, other end of diameter is known as antipode. Antipode of E in omega A. Okay, that can be proved. Huh? Followed? Is it clear to everybody? Huh?
Yes, miss.
Very good. Now coming back. Huh.
So what we just proved that the image of the X touch point is the antipode of D of in touch point.
Yeah, image of X touch point is antipode of in touch point in circle.
Ma'am, but what does that do?
Yeah, we will come to that. Okay, now pay attention. Now recollect that what is this distance? If D is a in circle, DC distance is how much? S minus C. Correct? Okay. And what is BE distance? BE
S
is
minus B.
S minus C. See, BD is S minus B, but X touch point is like this. So it is kind of reflection in the midpoint. Followed? D and E
Is the reflection in the midpoint.
midpoint. D and E are equidistant from this point. Understood? Followed? Huh?
This should be S minus B, right? The
No, wait, no, wait.
side
See, for in circle, it is S minus C, S minus B. But for X circle, it is
yes, miss. Yes, miss.
S minus C, S minus B. I hope everybody know this. Huh? Is there anybody who doesn't know this?
No, miss.
And can you please repeat?
See, the X touch point E will divide segment BC such that BE distance is S minus C and EC is S minus B. Adish, we have done this.
Yes, ma'am. Yes, ma'am.
Huh? Must be knowing it. Huh? Okay. Surya?
Oh, yes, ma'am. I heard D, sorry.
Acha, okay. Huh? Now. So, okay. So they are kind of reflection in the midpoint. Followed? Okay. E and D are reflection of each other in the midpoint of BC. Huh? Okay. Now, anybody have got this solution, or may I state the solution? So I can say that midpoint of ED is same as midpoint of BC. Now, okay, so everybody is ready for solution.
Ma'am, so are you talking about the intersection of IA and BC, or is that not?
No,
that's not what we're talking about, right? So why did you talk about that before then?
Achha, did I talk about that before?
I think so. I mean, I thought you were talking about AIA.
Sorry. No.
Okay, ma'am, sorry.
No, M is a midpoint of, maybe slip of tongue. Maybe slip of tongue. M is a midpoint of like ED and BC have same midpoint. So in old days, they used to call these points as isogonal points. Okay? Followed? Isotomic points. Not isogonal, isotomic. Nowadays, we don't use this terminology so much. Sorry, what happened? Okay. So how do I construct this point or construct this circle?
Ma'am, which point of its circle?
The original problem. In my original problem, I want to locate point A such that tangents from A, okay, will have will intersect L at points B and C such that omega is the in circle of the triangle and ABC, and M is a midpoint of BC.
First, mark the point, a distance of MD away from M on the other side.
Good. Other side, let us take E such that
Ma'am, it will be on the other side of M, right?
Other side of in touch point. Sorry. I want to take reflection of D. Correct. Okay, other side of M. Now my M is not so nice in this particular triangle. Let me take it. Okay, so suppose this is my M. Then let me take a reflection. Let E be. Okay, I don't have space to write. Is it okay if I clear this part?
Yes, ma'am.
Huh? Okay. So let me take a screenshot of this. And let me clear this part so I can write here. Huh? And may I clear the question?
Ma'am, in the other diagram, this one where we prove the lemma, could we say that if we were to use homothety on that midpoint of BC, such that B goes to E and C goes to D, will A go to I?
A go to I?
Yes, ma'am.
No.
No? Okay, ma'am.
I didn't understand. You are talking about this midpoint, na? M?
Yes, ma'am. Just asking. It just.
But homothety at M. Homothety, what is the center of your homothety? M.
M.
So B goes to C and E to D is correct.
Oh, okay.
Huh? This is correct. But how can A go to I? This homothety is, your reflection.
No, I'm asking if B were to go to E and C goes to D.
C goes to D. Okay. Then
where would A go?
Not sure.
Okay.
Not sure. We'll have to figure out the ratios. Then this will be a ratio. Suppose B is going to E. Okay. What do you mean by that? What will be the ratio of homothety? Ratio of homothety will be ratio. Suppose I take it K. K will be equal to EM upon BM. New upon old. Okay. That is A by 2 upon S minus C. Okay. Okay. Which is A upon A plus B minus C. So this will shrink in that ratio. So I don't know whether AM will, okay, where the point will be, image of A will be. Yes.
How A by 2?
BM is A by 2, no? This BC is side opposite to angle A.
So A by 2 should be down, right?
Sorry, A by 2 minus S minus C, I wanted to say. Sorry, A by 2 minus S minus C. Sorry, A by 2 minus S minus C. It will be like this. This is BM is A by 2 and upon A by 2. Sorry, upon A by 2.
Miss, but why is A, I, and M collinear?
A, I, and M. A, I, and M need not be even collinear. This point need not be M.
Yes.
M can be anywhere. Huh? Okay, so I really don't know. Huh? Okay. Followed? Okay. Now, here, coming back here, let E be the. May I clear this? Let E be the reflection of D in M. Okay, E be the reflection of D in M. Now, let us draw a circle. Consider a circle. And we know the center, I. Okay. And let us consider this ray, IM. Consider this ray IM. And let us draw a circle, another circle, such that that circle is tangent at E and having center on EM. Okay, having center on this ray. Okay, followed. Consider circle omega dash such that it is tangent to L at E and has center J at center J on ray IM and I dash M dash J, means it will lie on opposite side. Okay, followed? Is that clear?
Yes.
Now actually my M is off side, so it is okay. Sorry, actually let me draw it again, because my this line should cut my, I'll have to maybe reposition my D also. Okay, my IA. Okay, assume I lies on this. Okay, and then let me draw a circle. Followed? Something like this. Okay. Now so center, not J, I M, sorry, AM, AI, okay, such that AI and I want to say that, and yes, and it will lie on opposite side of this line, and I and J are on opposite side of line L. Okay, fine. Okay, so consider circle omega dash such that it is a tangent to L at point E. Followed? Okay, these points are quite close. Okay, where E is the reflection. Followed? Okay, is that clear to everybody? Is this much clear to everybody?
Yes.
Now draw tangents from A to. Now how will prove that? Now, but A I have to locate, right? Just a moment. Messing up.
And common tangents of the two circles.
I don't know point A, right? I want to figure out point A. How can I take ray AI? So does that mean? नहीं, एक मिनट. नहीं. Let me take. I've not encased this diameter. Correct. Consider this diameter. Okay, DF is a diameter, correct? Okay, now and I know that E is a reflection of D in M. Okay, now if I take this FE, okay, see, pay attention. What I'll do is, I will take I will consider F, which is the other end of diameter, and E, which is a reflection. Now consider ray EF. Consider ray EF. Okay. Now on this ray, I claim that okay, sorry, not this I wanted. Consider the reflection E and a second. Now I claim that and let F be antipode of T. Okay. Now claim required locus is the points on ray EF such that E dash F dash A. Okay, so they are these points. Okay, so suppose I drew the see, I don't want to construct A, right? I need to prove that what is a locus of A, right? So suppose I take any point A here, then now I'll prove that this is a required point, correct? Okay, so what I'll have to do, I'll have to draw the tangents, okay, and let me extend this tangents. Let me extend these tangents, followed, and now we'll prove that this is a required locus. That means, for given point M, these tangents will cut at such a point that M will be midpoint of BC. Okay, followed? So what I will do is, so what we can do is, we should take any point A on this ray and draw tangents AB, AC to omega with B and C on line L. Okay, and we extend it. Okay, now now we know that, okay, in this triangle we know this is S minus A, this is S minus A, and this is S minus B, S minus C. Okay, so we know that AD is S minus C and BD is S minus B. But we know that E being reflection of D in M, what I have is DC is equal to BE is equal to S minus C. That implies E will be X touch point. Correct? Followed? Is this clear what I'm talking? Is it clear to everybody? Any doubt, anybody?
No doubt, miss.
E, because of this, because we know X touch point is this, correct? Okay. So as a result, okay, what I will get that so yeah, and M is midpoint of ED, correct? Wait, no. Am I messing up? Just a moment. No. Wait, this I can't say. This I can't say. This I'll have to prove. If I start with this, I'll have to prove it. No, because of in-touch X-touch lemma, I can say that as due to lemma, we can say that as A, F and E are collinear, that implies E is X touch point. And because E is X touch point, BE should be equal to S minus C. So that implies BE is equal to DC, and therefore M is midpoint of ED. Okay? Is that clear?
Yes, miss.
Followed? Is this clear? I'll repeat again. See, what are we trying to prove? We are trying to prove that any point on this ray will lie on the locus. Followed? So that is our claim. Followed? So take any point A on this ray, and from any point we can draw such tangents. Correct? Okay. Now, so what I need to show that for any such point, my given M point will become the midpoint of BC, right? So to prove that, I will take AB and AC, okay, tangent to omega, then clearly by in-center, X-center lemma, okay, because A, F and E, we know that antipode of D and X touch point are collinear. Therefore, E will become X touch point. Okay. And therefore, BE will become S minus C. And therefore, BE is equal to DC. Correct. And because E is a reflection of M. So, EM is congruent to MD and BE is congruent to DC. Correct. These two are congruent. Okay. These both are S minus C. Followed. So they are congruent. Okay. And EM and MD are also congruent. So M will become midpoint. Is this much clear to everybody? Any doubt, anybody? Okay. So see what I mean by locus. Locus is to prove something is locus. To prove something is locus is equivalent in proving two things. that if point P lie on locus L, that implies P satisfy the condition. And conversely, if any point that satisfy the condition implies that point lies on locus. Okay? Are you getting me? If I want to prove that something is locus, then I need to prove two things. Because locus is a set of all possible points. Okay, so I need to prove these two things. Okay, so which part I have proved here? Who will tell me? Which part I have proved here?
Second part.
Think again. I have taken AB a line on the locus and proved that I get the condition fulfilled. So I have used first part. Now second part, conversely, okay, conversely what I will get? Conversely, let me prove the converse. Now conversely, what I need to prove? What I need to say, how do I prove it? Conversely, okay, I need to show that this, okay, so by in-center and ex-center lemma, by in-center ex-center lemma, clearly A will belong to ray EA, okay, followed. A will belong to A. If A is the required point, let me write it this way. If A is the required point, then A belong to ray EA, sorry, EF, such that E dash F dash A, correct? Okay, because I have proved the lemma separately, I don't have to discuss entire proof again. Is that clear? Is it clear to everybody? Now this is a complete proof. Is it clear to everybody? Any doubt, anybody? So required locus is the part of ray EF such that dash dash. Required locus is set of, or you can say a part of ray, okay? Followed. Better wordings is required locus is points on ray EF that are on other side of, or okay, better wordings will be required locus will be the opposite ray of ray FE. What happened? The screen went. What happened suddenly? Can I get it? No. Have you people take a screenshot or something?
Yes, ma'am. I have taken a screenshot.
Adish, of the latest proof?
Yes, ma'am.
Adish, can you please share on WhatsApp?
Okay, ma'am.
Okay, I can say that the required locus will be, will be the opposite ray of ray. Okay, we can say like that. Is this clear to everybody? Huh? Any doubt, anybody? Huh. This was a IMO problem. Okay. Followed? Adisha shared the screenshot on the group. Huh? Any doubt, anybody? Then I can repeat it.
Ma'am, in the exam, can we directly use this lemma? First, we have to prove it.
Yeah. You can use this lemma. Okay. It is a famous lemma, Adish. You can use it.
Okay.
Sharing is paused. Acha. Okay, sorry. I thought. Okay. Acha. Now, can you see this proof? Huh? Okay. Any doubt, anybody? No. Now, let us go to the next problem. Give me a while to share the worksheet. Okay. Okay. ठीक है, एक काम करते हैं. Let me do little theory of homotheity and then we can do some range of problems. Yes. Let us do the combination of two homotheities. Okay? Huh? Let us do the combination of two homotheities. Let us see what it is. Okay? Now, suppose let us consider a homotheity that takes a point, homotheity at center O that takes a point P to Q. Okay? And homotheity at some other center J, center J that takes Q to R. Okay. Then sorry. एक minute, let me draw a better figure. Basically, what I want to prove, suppose homotheity at center O with ratio R, okay, its combination with homotheity at center J with ratio K, okay, followed, is again a homotheity with ratio K into R and center is some X, okay, then X is collinear with J and O. Then prove that X is collinear with J and O. Or better wordings would be that X belongs to line JO. Okay? And the ratio of the homotheity will be K. Okay, to prove this, what we'll do is we'll consider a segment Now consider a segment AB, and under this homothety, it has become A prime, B prime, suppose. Okay. So suppose this is my O and this is AB and it has become A prime, B prime. Okay. Huh? And consider another center J. Okay, and let me apply homothety from J. Okay, and that is taking this to or better I call this A1, B1, and that is taking it to A2, B2, another center with homothety J, that is taking it to A2, B2. So what I need to prove that their combination is the third homothety. So what is that? That is the third homothety, and I need to show that this homothety, okay, is with, okay, a center will be some center X, okay, such that OX and
J are collinear.
No, see, in my figure, they are not coming properly, but they should be good. Okay, followed? Huh? Is that clear to you? What I want to prove?
Yes.
Now how I can prove this? So first, ratio is very easy to prove. How? Because A1, B1 will be K times AB and A2, B2 will be equal to R times A1, B1. Correct? Because of ratio of homothety. So that is KR times AB. Correct? Followed? So ratio is KR. Now I need to show that these are collinear. So can we, I think we can use manula in some triangle.
And what is the name of this theorem? Like you started with some
composition of homotheties.
Okay, ma'am.
What about OB1J?
O,
B1J.
B1 and J. O, B1, J में, okay. Yeah, I think it will do. So consider in triangle OB1J, consider the transversal but we need to prove X lies here, no? So नहीं बेटा, नहीं OB1J से नहीं प्रूव होगा, क्योंकि मुझे क्या प्रूव करना है? What I need to prove that X lies on OJ, correct? Okay.
So point such that XB2 equals.
नहीं. So I need to use Mendelaw's theorem. Mendelaw's theorem. What Mendelaw's theorem says that the everybody know Mendelaw's theorem. Okay. Everybody know Mendelaw's theorem. Suppose this is my triangle ABC and this is the transversal, cutting it at points PQR. Okay. Then what I have? PP upon CP and CQ upon QA and AR upon RB.
R multiplied by 1.
Yeah. QA into AR by RB. Okay, you start from one side and go on along the triangle. If this ratio, product of ratio Okay, taken these as lengths is equal to 1, or if you take vectors then -1 because BC and CP are in opposite direction. Correct?
Ma'am, but what does it mean to divide vectors? Okay, since they're the same direction, it's okay.
Direction. Okay. Then this is one if and only if P, Q, R are collinear. So we'll show for some triangle these ratios as well. Okay. Followed. So I'll have to select some triangle such that, what about A1? No.
This the transversal is OXG, na?
Transversal is OXG.
Yes.
Transversal is OXG, and if I take A1, A2, then yes, consider triangle A1, A2. Okay, with transversal OXJ. Okay, followed. So what I have is, now see, initially I'm not claiming that they are collinear. Followed. I'm just saying that consider a point O on this segment. What do you mean by Mendel's? I'm considering a point P on side BC, Q on side AC, and R on side AB are such points that they satisfy this condition. The product of ratio is -1. Then we conclude that P dash Q dash R. Okay, followed. Therefore now, so what I will get? So now I'll start from A. So what I will get, OA upon OA1 into, okay, this is my triangle, correct? Okay, so OA upon OA1 into A1J upon A2 into A2X upon OX.
Name is AX upon A2X.
No, beta, I'm at A2. I started from A. Correct, Raghav? Correct? Now A2 to J, then J to A2, now A2 to X upon XA. Okay? So I need to figure out what is this. Now OA distance is some X, suppose. Okay? Because we don't know what is this distance. OA is X, then we, okay, or no need to even take this distance. We know this ratio. We know OA by OA1 is how much? That is nothing but K, no, 1 by K, no? Sorry, 1 by R. First homothety is R. Sorry, this will be 1 by R. 1 by R. Then A1J upon JA2. Okay, this is the second homothety, so this will be 1 by K, and A2X upon this will be KR, so this has to be 1, correct? So this proves that implies the centers of homothety are collinear. Is this clear to everybody?
Yes, miss.
Now we can even figure out what this ratio would be, right? Okay. For finding out the ratios, we will take help of any one of this triangle. Like he suggested the triangle OB1J. Okay. Consider now triangle OB1J. Now in triangle OB1J, what you have? Okay, consider this as transversal. Okay, So what we have is OX upon XJ into JB2. Now I'm considering this triangle, okay? O, B1 and J as a triangle, and with transversal XB, B2 is transversal, okay? Followed? Huh? Then we know that XB, B2 are collinear. Therefore,
What are we taking X as right now?
now we know that X is the center. Now we know X lies on OJ, right? Huh? Okay. So,
Okay, ma'am.
so I'm trying to use converse of Manila to figure out what this ratio would be. Huh? Okay.
Okay.
So we are taking that this transversal cuts it, then the product of ratio should be -1, correct? So now I'll get OX upon XJ is equal to JB2 upon B2B1 into JB2 upon B2B1 into B1B upon BO. Okay, followed, is equal to -1, which is 1 in our case. We are considering segments. Now, what is this ratio JB2 upon B2B1? How much this ratio would be? See now, okay, let me take this original segment OB as X. Let OB be X. Therefore, OB1 is XR. Then let JB1 be Y. Then JB2 is KY, correct? Okay. Followed? Whole will be KY. Okay. Now therefore OX upon XJ into JB2, that is KY, upon BB2 will be what? K minus 1Y. So this is K upon K minus 1. Correct? Can you see that? This whole is KY. So this part will be K minus 1Y. This part will be K minus 1 times Y. This whole is Kx. So BB1 will K minus 1 X. Correct? So BB1 is K minus 1 X and OB is simply X. Correct? Okay. And here it is correct. No. Here it is JB2. Okay. Correct it is. Am I doing some mistake? No, no.
Miss, it should be R, right?
This should be R, not correct. You are right. This should be not K. This should be R. No, what? Hey, this should be K. This should be R. Sorry. Here it should be R minus X. Yeah. BB1 should be R minus 1 times X upon OB, it's simply X, no? Is equal to 1. So OX upon XJ will become K minus 1 upon K into R minus 1. Okay? ratio is not that friendly, but we get some ratio, correct? Okay. Can you see that? Huh? Let us check the calculation once again, because I'm not getting a very symmetric ratio. It need not be symmetric because first homothety is followed by the second homothety, right? This is correct. This is y, then this is ky. This is x, then OB1 is Rx. So this is R minus 1 times x, correct. So this is k upon k minus 1y, and this is, let me clear this. So this will be k R minus 1 times x, correct. Okay. Yes. So I will get this as a ratio. Okay. Is this clear to everybody? This is page number. Okay. Is this property clear to everybody? Huh? Any doubt, anybody?
Miss, we can use this ratio in the exam RMO.
No, this is not so very famous. If you want to use it, you will have to prove it, derive it.
Okay, Miss.
This is not like, I don't even like, I just for sake of showing that we can derive the ratio I've shown. I don't remember I have used it ever. That's why something which is not used, you kind of can't remember. Okay.
Yes, Miss.
Now let us see problem based on composition of homothety, then you will understand the importance of this. Now, okay, so now, suppose I have, you usually have problems like this, that why you writing on my screen, beta? Neon. Okay, now, suppose this is divided in the ratio say 1:2, and this is divided in the ratio say 3:4, and this is my point x. Okay, I need to figure out what is BP by XP and CX by QX. Okay, one method is, if you recollect, that you have to, this method also works, you have to divide this into triangles, either this way or this way, okay? And then take the triangles with collinear basis and same vertex, and then you keep on labeling them, you know, like you can label this as x, this is as 2x, then this is 3y, and this is 4y, and then this will be so many times this, and then like that you can play around. Okay, see, like I can write this in terms of this, that that AP upon PC is 3:4. So I can derive area of XBC, and then I can use the fact, whatever area I'll get, I can use a fact that this upon this is 1:2. Okay, so you will get two equations, and then you will get the ratio of x as to y. Okay, and using the relation between x and y, you can figure out the areas. Okay, you want me to show the method in detail, or you understood?
Understood.
Anybody wants me to show? Okay, no. So it is easy method, but a bit of calculation and lengthy method, right? Now let us see one more method. What we'll do in this method is, first I will apply homotheity at center Q with ratio half, negative half. Okay, negative means what? Point will go to other side. So what will be image of B?
A.
A. Okay. Now at A, now I will apply homotheity at C, that will take A to P. Means what? Means my, okay, I want what resultant I want? I want A to go to P. Okay, that means CP, ratio of homotheity should be CA upon CP. Sorry, nahin, the final is CP. So CP by CA. So what is ratio of homotheity? 4/7. Got it? Ratio of homotheity should be 4/7. So consider the combination of these homotheities. First, we will apply homotheity at Q, followed by homotheity at C with ratio 4/7. So their combination, let us call it homotheity at some point T with some center T. And what will be the ratio? I know it will be -2/7, correct? Now pay attention. Now,
Miss, it literally gets multiplied, the two numbers.
yeah, literally get multiplied, the ratio. We have proved here, na?
Yes,
We have proved here, that is KR. Because see,
yes.
the A1 B1 will be K times AB and A2 B2 will be R times A1 B1.
Yes.
Huh?
Miss.
Okay. Now, therefore, what you will get? Therefore, center, now this homotheity, HT minus 2/7 will
Base point T. Base point T.
T is the center of this combination.
Okay.
Center of this third homotheity. That is such that it is taking B to which point? Firstly, B will be taken to A along first homotheity, and by second homotheity it will be taken to P. So B will go to P under this combination. Correct? Is this part clear to everybody?
Yes,
Yes, miss.
Now, therefore, I know that the center of this homotheity of combination of homotheities, okay, will be collinear with the centers of homotheities.
Yes, miss.
So that implies T must belong to line what? QC.
BP.
No, centers of homotheities, QC.
QC.
But it is taking P to B. So T must lie on BP also. So what does that imply? That implies T is
intersection of QC and
BP. Followed? So this point X will divide this in what ratio?
2:7.
Yeah. But see, ratio will be what? New upon old is homotheity ratio is always new upon
Yes,
old.
yes. So 7:2.
Yeah. 2:7. P to B will be divided in the ratio of homotheity. Okay? Remember, ratio of homotheity will be always new upon old. Okay,
Yes,
is this clear? Okay, now you people figure out what will be this ratio. Can I come in 2 minutes? I'll take a just 2 minutes break.
Sure, ma'am.
Is it 1:4? Sorry, 1:2.
Yes, 1:4 is the correct answer. Okay. Everybody is ready for solution. Everybody is ready for solution. Please respond.
No, ma'am. Can you please wait?
Yeah, sure. No problem. No problem, beta. Is it okay if I hunt for some good problems for you? I'll just make it small.
Yes, ma'am.
Okay. You tell me when you are ready. Are you ready? Huh? For
Yes,
the
ma'am.
Yes, ma'am.
you will tell me now. I won't say the solution now. Somebody should say the solution.
Ma'am, can I try?
Yeah, sure. Sorry.
Ma'am, if we take homo-30,
Somebody want me to wait?
No, I was gonna ask to give a solution.
Acha, nahi. Adish wants to give the solution. Beta. Adish, yes.
yes, ma'am. If we take homo-30 with center P and ratio -3/4, then we will get C. C will go to A.
Correct.
And then if we'll take homo-30 with center B and ratio 2/3.
Give me a while to write it down so that people will understand. Consider homo-30 with center P and ratio
-3/4.
Okay. That will surely take C to
A.
Okay. Let us draw. Okay. This homo-30 is taking my C to A. Correct. Okay. Now I want homo-30 that will take A to Q. So
yes,
what should be the center?
B.
B. Correct.
And ratio 2/3.
And ratio
2/3.
Correct. So that will take my A to Q. So let center of combination of this homo-30 is?
I took V.
B, V. Okay. So HV ratio will be what?
-1/2.
-1/2. Correct. Okay.
Yes, ma'am. And C will go to Q in that.
And C will go to Q. Correct. Therefore, clearly C. So V belongs to line CQ, and V also belongs to line PB. So that implies V is of intersection of CQ intersection PB. Therefore, I will get that here. Okay.
2x/xc = 1:2.
Followed?
Yes, ma'am.
QV by. Okay. Is this clear to everybody?
Yes.
Page number I don't remember now. Okay. What is the page number? No.
Ma'am, would this warrant saying just similarly we get the other thing?
Yeah.
Other ratio?
Yeah, correct. Just a moment. Yeah. Sorry, beta. What you were saying, Surya?
Would we be allowed to say that use similarly here?
If you show one proof, it is allowed. I just gave you a practice.
Okay, ma'am. Yes, ma'am.
Okay. In the exam, yes. If you show one, then definitely you don't have to write second again. Okay. Next is what? Next is I want to share a problem. मैंने क्या problem सोचा था? Okay. This is a cute problem. I don't know whether I'll be able to draw the figure properly, but let us see. Okay, now see, these are kind of twin problems. अरे नहीं, ये tangent हुआ ही नहीं. Okay. It's very difficult to draw this. Okay, so this is one tangent and this is second tangent. Okay, now and I want to draw common tangents to these two circles also. So what I'm doing is I'm taking the pair of direct common tangents. Can you see that?
Yes.
I'm taking the pair of direct common tangents to these three circles. Suppose these three circles are centers ABC and radii are distinct. I've taken distinct radii. Why? What will happen if the radii are same?
Tangents will be parallel.
Because they won't intersect.
Yeah, tangent won't intersect. And I want intersecting tangents. Okay, because what I wish to prove is that if I have these three circles with centers A, B, C, and without loss of generality, suppose their radii B small a, small b, small c, so that everybody will talk into same terminology. I want you to prove that these tangents, the point of intersection of these tangent segments are collinear. Now, in my case, it is not collinear at all. Okay, so you assume. Okay, some tangent has messed up somewhere. I think these two tangents are messed up. Okay, so try to prove they are collinear.
Yeah, no.
Done. Very good. I have kind of like three proofs for this. I prefer GeoGebra for such kind of accurate figures. Arkan, beta, once you have to remove little time to teach me GeoGebra.
Okay, ma'am.
A GeoGebra screen, can I share?
Yes, miss.
Okay. On Zoom chat also, that I will have to figure it out.
Zoom chat?
I mean, Zoom lecture, the way.
Yes, miss, you can present your whole screen.
नहीं ये भी नहीं जा रहा है. Okay, you people assume they are collinear. Okay, huh? So I'm just going to.
Isn't it better to see them not collinear and then prove that they are?
Okay. Okay. Yeah. Because I don't even know whether this is circle. This C thing doesn't look like circle to me. Okay. Now. Yes. So who will present the proof? Or you want little? You can take time. Yes. And similar result for transverse common tangents also we have. I'll show that also. Yes. Who will present the proof? Or you want some time, then you take your time. Sorry. Okay.
Miss done.
Done. Everybody is ready for discussion. Okay. This is the second problem which I give for homework.
In terms of writing the proof, it will be identical, right?
No.
Oh, right, because we need to mention the radii and all. Right, sorry.
No, still it won't be identical. The idea is totally different. In this proof and this proof, we are using different concepts. Like kind of similar proof, but properties used will be different. Here, transverse common tangent intersect at point X, Y, and Z. Then you have to prove they are concurrent. Okay. Now, are we ready for proof? Discussion?
Yes, ma'am.
Yes. Who will tell me proof? Who wanted to tell proof?
I did.
Yes.
So we know that if we perform homotherty through R on C with ratio of B by C, small b by small c,
correct,
we will the image of C, circle C will be circle B.
Small b by C will take circle C to circle B. Correct.
And the homotherty through P with ratio A by B, small a.
By small b will take circle B to circle A. Okay, so combination of this homotherties.
We have ratio A by C.
Yes. So new homotherty, let us call it center, and this will be the homotherty, which is combination of these two homotherties. So ratio will be A by C, correct? Okay.
Yes,
and we know that the only homotherties that, at this point we know, okay, wait, let me erase this. Now we know that this point of direct common tangents, okay, followed, divide AC externally in the ratio A by C. And because A by C is positive, I want A and C on the same side of this. Correct? Followed? So that implies that, so we know that the point on AC that divides CA in externally in ratio A by A by C I want now, so I want AC externally. Sorry, AC externally in ratio A as to C. A as to C is point of intersection of like exterior point of similitude. Everybody know similitude word? Huh? Everybody?
No.
No. Okay. Okay. Then point of intersection of direct common tangents. Okay. Followed. This is direct point of intersection of direct common tangents, and transverse common tangents are known as points of similitude. Okay. Nowadays nobody use this words, but just okay. Followed, you can simply write point of intersection of direct common tangents. Okay, which is nothing but Q. Okay, therefore we get that HQ A by C is equal to HP A by C. Sorry, combination of HR A by C and HP A by C is this, which implies that P dash Q dash R, they are collinear. Okay.
Ma'am, what exactly would we have to prove that C goes to B and B goes to A under those two homotheties?
See, I need to figure out what is the center of this homotety.
No, ma'am, before.
Sorry.
Before in the first two statements, would we have to prove that C goes to B?
No.
Or is it trivial?
That is obvious, na?
Okay, ma'am. Trivial. Okay.
That is trivial. That is trivial. Okay. We need, that is trivial. That you don't have to write. See, if I take any two circles, 2 minutes, I'll go back to that screen. I just want to explain this. If I take any two circles, okay, then there is, let me make this a little smaller. This is not look, imagine it is a circle. Now I don't have time. Then I have, exactly two homotheties. Taking one circle to other. One is the point of x-similitude. That means the direct common tangent intersection point. One is point of intersection of transverse common tangents. Okay, followed? Is that clear? Will definitely take circle omega and omega 1. They will swipe circles omega and omega 1. And both homotheties will have ratio R1 by R2. Okay. Okay, let me write it this way. So omega 2 to omega 1. Okay. If you take P, ratio will be positive, and if you take Q, ratio will be negative. Followed? So given any two circles, there always exist these two homotheties. Okay. Okay. So point P and Q divides internally and externally. Externally and internally. Divides segment AB externally and internally in the ratio R1 as to, segment AB, no? So R2 as to R1. Followed? Okay, is this clear to everybody? Everybody know this as a property in circles?
Yes, miss.
Divide externally
Yes.
as in PB by PA.
PB by P. See, what do you mean by external division? That means P divides AB externally means what? That
So lines from P to endpoints.
upon BP is R1 by R2. Okay. And Q divides internally means what? AQ by BQ is R1 by R2. Okay. Is that clear to everybody? Even these tangent segments are also in that proportion. Followed? Because this is a homotety, na? Followed? Homotety means the entire figure will go to this. Followed? So if the tangent segments means this triangle will go to this triangle, like that. Okay? This cyclic quadrilateral will go to this cyclic quadrilateral. Everybody understood this? Any doubt, anybody? We know this from basic properties of circle. Okay, I'm just specifying it as properties of homotety. Okay, now coming back to our figure. Is the first proof clear to everybody? Is the first proof?
Yes.
Okay, so we are ready for the second proof. But remember that if you don't prove that Q is the center of homotety, you will lose marks. And here half the credit you will lose. This is very important point. Okay. Now, okay. Now, second proof. Who will tell me any other proof anybody has? What can we use? Can we use Menelaus on some triangle? Can we use Menelaus on ABC? Can we use Menelaus on ABC? Yes. Who can tell me proof using Menelaus? Consider triangle ABC and transversal.
Mummy.
Yeah, please.
So we'd be talking about RC by, would we have to start on the vertex of the triangle, or could we start from
anywhere you can start, but it's better you start on vertex. It goes clean and neat. So start from A.
So AB, sorry, AP by PB into BR times R by RC
into CQ,
into CQ by Q
will be equal to how much? AP is what? Small a, and BP is small b. This ratio we know. And PR by CR ratio is how much? B by C, and CQ by CA is equal to 1. So that implies P dash Q dash R. Okay? This is by Menelaus theorem. Proof by Menelaus. So this is proof number 2. Third proof, many people must be knowing it. This is one of my favorite proof. Okay. You kind of imagine for proof 3, okay, consider the 3D image of this figure. So what we have spheres with center. So we have spheres with centers. Is it okay if I dictate this proof rather than writing? First, let me explain and then I'll dictate. Okay, so imagine the 3D image of these. Okay, so imagine instead of circles, its 3D image will be spheres, right? Okay. Now, I want to take the spheres in such a way that this my screen, okay, computer screen, whatever, is a plane that cuts the sphere in exactly half hemispheres. So half of the sphere is coming out from screen and half of the sphere is behind the screen. Okay? Everybody understood this much? Any doubt, anybody? Please respond.
No,
understood.
Now, tell me what will be the 3D image of tangents?
Cones
or
tangents.
Correct, cones. And this is like, imagine I have one tiny ice cream ball at B and other big ice cream ball at A, something like that. So cones, okay, followed with 2 ice cream balls inside. And what will be the vertex of this cone with balls AB?
P.
P will be the vertex of this cone. So every line that is tangent to these balls A and B must pass through P. Correct? Is this much clear to everybody?
Yes, ma'am.
Yes. Yes, ma'am.
Okay. And what I'm doing is my computer screen is a planar section of this 3D figure, right? My computer screen is a planar section of this 3D figure. Okay. So all these points A, B, C, P, Q, R will lie in my computer screen. Okay. Let me call the plane of my computer screen as H1. Okay. H1 will be the plane of my computer screen. So all these points and whatever lines I have drawn will all lie in my H1. Okay. Now imagine that my H1 is flat. Okay. Horizontal. Okay. Assume my H1 as horizontal. and I'm putting another plane H2 on top of these 3 balls. Correct? Okay. 3 cones rather. Now cones are not of same size. Okay. Okay. So another plane H2 followed, because the radii are distinct. Can H2 be parallel to H1?
No.
No.
When I
There will be an inclination along AC, AB.
So when I keep H2, okay, there will be one tangent, one part of the cone that will touch H2, correct? So my cone will be, H2 will be tangent to the cone. Can you see that? Can you visualize that?
H2 will be along the cones, right?
No, it will be on top of the cones.
The 3 corners, the three
See?
corners on the top of the 3 corners, right?
On top of all cones.
Matlab 3 cones are only there, na?
Yeah, it will rest on 3 cones. Correct? Now, first visualize only one cone. So my H2 will be on top of that cone. See, my H1 is slicing the cones in the middle, slicing the spheres in the middle, and it is horizontal. Now imagine 3 semicircles are coming out, okay, of a flat horizontal. So imagine that these semicircles are kept on a horizontal surface. I am resting a metal sheet or whatever sheet on the paper sheet on this semicircles. Okay. Followed? Is that clear?
Yes, miss.
So, ma'am, it will be the cone will lie on the projections of A, B, and C upwards, right?
Yes, correct. So clearly there will be a single common tangent of these spheres, which is single line of the cone, will lie in H2, correct? Follow?
Yes, ma'am.
Is this part clear? I'm saying that a single line of cone, that is single direct common tangent, of spheres A and B, okay, will belong to plane H2, correct? Is this concept clear to everybody? This is main important concept. Any doubt, anybody? Please respond.
No, miss.
Everybody understood this? Very good. So similarly, one common tangent of AC will lie in H2, one common tangent of BC will lie in H2. Now all these common tangents will pass through the vertex, correct? So what can I say about PQR? Will PQR belong to H2? Will they belong to H2?
Yes, ma'am.
Everybody can see how PQR belonging to H2?
Yes, miss.
Okay.
So we want to prove that the intersection of H2 and H1 is PQR.
Yes. So PQR will belong to H1 intersection H2. What is intersection of 2 planes?
A straight line.
A straight line.
Therefore, they are collinear. Got it?
Ma'am, so we can say that we can be sure that we can find a plane H2 because AC is just a consequence of AB and BC, right? The tangents, slopes of those tangents.
Sorry, can you repeat?
Sorry, ma'am, that was so we can be sure that such a plane exists where all the common tangents lie on it because AC is actually just a consequence of the lines tangents of AB and BC,
I don't
right?
understand. What do you mean by AC is consequences of?
Like it's not independent of those two, right? Once you have those two fixed, AC is fixed, right? Because normally we can't be sure that that 3 lines lie in a plane, but we can be sure that 2 lines do.
Yeah, here basically what I'm doing is here I am sure because I'm taking the 3D version. Okay, So if I have 3 cones, okay, there will be a plane resting on it. That is common logic.
Okay, ma'am.
Right? So we have the connecting lines resting on it. Got it? Followed?
Okay, ma'am. I was saying that if we have an tangent of A and B and B and C, then AC is fixed.
Yeah, I understood your point, but
Yes, ma'am, that's unnecessarily.
Yeah, okay.
Too many.
Huh? Is this clear? Huh? Okay. So what we do in projective geometry, we kind of convert 3D problems into 2D, or we take projections and we solve the problem. So this is like a rare problem in projective where I'm converting a 2D problem into 3D. Usually we take projections and we solve the problem in projective geometry. Okay. I hope you enjoyed this proof. Any doubt? Huh? Any doubt, anybody?
No, miss.
You want me to dictate the proof?
No, ma'am.
Huh? No. Okay, wrong question. Anybody want me to dictate the proof? Okay, very good. So shall we proceed further? Huh? Okay. So just... And this I'm giving for homework. It is not a transformation problem. This is just simple geometry. Now, okay, go to the worksheet and okay, this is a very nice problem. Second problem. Can you see the worksheet now?
Yes, miss.
Yes, ma'am.
HB the orthocenter of this and lie inside it. These be circumcenter of HBC, HCA, AHB respectively. Show that AA dash, BB dash, CC dash are concurrent and identify the point of concurrency. ABC are orthocenters of these respectively, and circumcenter of HBC, HAC, HAB and ABC are congruent. Okay. So what I need to prove is this. Suppose this is my circumcircle of ABC, and suppose I have these sides of ABC. This doesn't look like 90. See, when you are trying to draw these figures, use compass and draw proper figure when you are drawing on a paper. Okay, I want everybody to use properly compass and draw proper figures. Okay, that doesn't mean you have to do construction, but at least first circle you draw by compass, and with scale you can draw roughly perpendicular. Huh? Okay, now this is my edge. Now I am facing a problem. Okay, is it okay if I draw this on the whiteboard? Huh?
Okay.
Okay. Everybody has noted down the problem. Because on whiteboard you can draw a little more neatly. Okay, so what I want is, I want a circle. I have something like this figure. Okay. Okay. Now, suppose their centers are whatever. Yeah, this is B dash, this center is A dash, and this center is C dash. Then what I have to prove? First thing I need to prove is they are concurrent, right? C dash are concurrent. And secondly, circumcenters of A, H, B, A, H, C and BHC circumcircles, sorry, not centers, and ABC are congruent, correct? Huh? Circumcircles of these are congruent. What was the third point? Huh? Anybody can tell me? Anybody has taken screenshot? Huh? Anybody has taken screenshot?
Ma'am, we have to prove that the circumcircles are congruent.
And one more
Ma'am,
point.
only that much. All the three circumcircles.
Only that much?
I will check.
नहीं, एक minute, huh? एक minute. Let me slide this and check it out in the worksheet. Worksheet. हाँ, circumcircles. हाँ, ABC are orthocenters. हाँ, and ABC are orthocenters of PHC, AHC and AHB respectively. Okay, these three things. Okay, now
How can ABC be?
नहीं, A comma B comma C मतलब A is orthocenter of HBC. Okay, isn't it obvious from the figure that A is?
Oh, right. Sorry, ma'am. I just saw outside the triangle and I immediately got confused.
Okay. Yeah. That is obvious. मतलब no need to prove. We can see it from the figure. Okay. Well, HC will act as a AB will act as a no.
Ma'am, AC will act as FC will act as the base.
FC is base and from
AB is positive.
Yes, BF is altitude on HC, on side HC, okay, and CE is altitude on BH, correct? Followed? So they will meet at point extended altitudes meet at point A, correct? Followed. Therefore, A is orthocenter of triangle BHC. This is quite obvious. A dash, B dash, C dash are what circumcenters of these? Just a moment. Huh? Just a moment. Circumcenters of these. Okay. Correct.
Ma'am, I think I remember some property about the reflection of the opposite side, opposite vortex.
Orthocenter. Yes. See, it's
What was it, ma'am?
yeah, it's like this that yes. Yeah. Suppose I have a triangle. Reflection of orthocenter in opposite side will lie on the triangle. There are two properties. One is this, that suppose I take this reflection of orthocenter suppose H is okay, I'll take reflection of H inside BC, then D dash, then it will lie on the circle. Okay. Similarly, E dash is a reflection of H in side AC, and F dash is a reflection of H in side AB. Huh?
Opposite vortex? There was one more about that.
Yeah. Wait. Second one is that if I take a reflection of H in midpoint of BC, it will also lie on the circle, okay, and it will be antipode of A. Followed? So suppose I call it A dash I've used na here. Sorry, so let me call it A2, okay. So A2 is, then center will lie here, A2, then this is midpoint of BC, okay, then these are equal, correct, okay, followed like that, where this is other end of diameter from A, okay.
Yes, thank you.
Okay, now here, should I give hint?
Please say. Solving.
Can't understand. You want hint or you don't want?
No, ma'am.
Achha, okay. This property will help you to prove one thing.
I asked a doubt in the Zoom chat.
Sorry, you asked a doubt. Okay.
In the chat, ma'am.
Yeah, I'll check. Perpendicular from, can we say if perpendicular is from the same point of a common chord? I didn't get where the common point is.
Common point on the chord, sorry.
So how can you draw perpendicular to the chord from the point?
To the circle, ma'am. From a common point on the chord to the circle, dropping perpendiculars on both circles.
To the circle?
Sorry, ma'am. So two intersecting circles, there's a common chord, right? And if you draw perpendiculars from the chord, draw a line perpendicular, not drop onto the chord. Sorry, draw a line perpendicular from the chord, from the same point onto the two circles.
I didn't get.
From the chord, draw perpendiculars.
From the chord, how perpendicular means?
To the circles. Just draw a line perpendicular to both chords.
At which point?
Any point on the chord.
Any point on the chord? A line perpendicular to this chord, you want to say?
Yes, ma'am.
What do you mean by perpendicular to circle, beta? There is nothing called perpendicular to circle.
Did I say perpendicular to circle?
Yeah. Okay, ठीक है.
Perpendicular from same point on chord onto the circles.
Okay, ठीक है. Then, yeah, if you want to say whether these lengths are equal, then circles are congruent. Yes.
Okay, ma'am. Then I have the.
I think we can prove this because.
Ma'am, or we can say that like a circle is uniquely described by 3 points, right? So then we can. So then we have.
Check midpoints of the chords. Okay. Suppose let me label it. This is no. I have already labeled AB. Then you want me to label what? Want me to label P, Q, and R, S, and suppose midpoint is MN. Then.
And I'm saying that, ma'am, can you mark the point of the perpendicular lines? Point where they intersect.
P.
So I'm saying that if ST equals PT.
Then the circles have same radii, right?
Yes, ma'am. That's what I'm asking.
ST, can we prove ST equal to PT? Then circles have same radii. Means this common chord is perpendicular bisector of PS, correct?
Yes, ma'am.
Therefore, now suppose I take say centers of circles as something like O1, O2. Okay, then clearly common chord is perpendicular bisector of O1, O2 also.
Yes, ma'am.
Okay, that means these two will become parallel.
Yes, ma'am.
Therefore, this distance of common chord
rectangle.
Correct. Okay. And because ST is equal to TP, can we show that TQ is equal to TR?
Okay.
Yes, we can show. See, pay attention. ST into TR is equal to power of T, which is AT into BT.
Ma'am, I think I have a shorter proof.
Yeah, okay.
If we rotate around T, half turn around T,
yeah,
then P will go to S, A will go to B, B will go to A, and circles are uniquely described by 3 points, right? So
sorry,
the whole circle must
go to B, because T is any point. T is not your midpoint of AB.
Sorry, right. So then we can just say that.
Know that circles are congruent.
Can we say that if we prove that the triangles are congruent, like the.
This is done, beta. This is almost done. See, AT into BT will be also equal to PQ into PQ. PT, correct? Followed? And we know that TS is PT. Okay, so
Yes,
TR is equal to TQ. Now once TR is equal to TQ, okay,
okay.
then and these, so you have MR is equal to MQ, so MT is equal to TQ, correct?
Yes, ma'am.
Now once MT is equal to TQ, then I can join the radii, and because I have already proved these two equal, radii are also same.
Okay.
This was easy but quite not that obvious, but yes, true.
Ma'am, or
What he was saying,
instead of half turn,
just
could we just, if we prove that PAB is congruent to SAB?
just has now what was the label? I seriously don't remember. We will try to. I think this point was T.
T, ma'am. T and S. S on the other side.
S.
No,
T.
ma'am, the other side.
This is Q was here,
Okay,
no?
ma'am.
And
I
this
don't remember.
This was R. Okay.
I think so. Ma'am, so if we prove that PAB is congruent to QAB, would that be enough?
PAB.
Yes, ma'am.
Triangle
Yes, ma'am.
is congruent to QAB. Will that be enough? I don't get you. Why that be enough?
Right. Is there a radius? Can we find radius from properties of the triangle? Circumradius.
Yeah, we can find.
So then it's done, right? Because then if the triangles are congruent, circumradii must be same, right?
Yeah, triangles are congruent, circumradii are same.
And it's easy. Its height is same, base is same.
Height is
So
same.
triangles are congruent, right?
I mean, see, actually, because this is easy. See, because PT नहीं, but एक सेकंड नहीं बच्चा, तुमने क्या बोला था? PT.
Sorry, not height same, base same. I meant we can show the side is same using Pythagoras, and then
PT is equal to TQ. So PQ will be perpendicular bisector. AB is perpendicular bisector of PQ, and AB. That's why I will get these two equal. PA is equal to AQ, and I will get other two sides also equal. PB is equal to BQ.
yes.
And this is a common side. So these two triangles are congruent. No. You said PT is TQ, no? Or
yes, ma'am. PT is TQ.
Then correct.
Okay, right. Sorry, height and base are same, and height divides it into same ratio.
SSS beta.
Okay.
SSS. The triangles are congruent. So triangle ABP is congruent to triangle ABQ. Okay. And
do we use this in the other proof, right?
You can use.
I mean, okay. So
these two angles are same, and using sine rule. Okay. So PA upon PA is equal to what? PA is equal to using sine rule, you will get PA upon sine theta, which is 2 times R1, is same as QA upon sine theta, which is 2 times R2. Okay, so R1 is equal to R2. I kind of forgot that you people have done trigonometry. Everybody in this class has done trigonometry?
Yes,
ma'am.
In RMO, I have not done. But in IJSO, they are teaching now trigonometry.
Yeah. That's why I was doing a primitive proof. This is a senior class, no? Okay. See, for primitive proof beta, what I can do is I can draw perpendiculars from this, and then you have to do a quite a bit jugglery. Huh? But we can do it. Okay. You can do it basically. You have to draw perpendiculars and then prove this is parallel to this, because you know O1 O2 is also AB is also perpendicular bisector of this, and then using all those tiny things you prove this segment is equal to this segment, and then ultimately you have to show SR is equal to ये क्या था? अच्छा ये S है मेरा, sorry, there's so many points to confuse you. Okay, ये M है और ये N है. And then you prove MR, segment MR is congruent to segment SN. Once you show this, then you know this is congruent to this. So Pythagoras लगाओ फिर radius आ जाए. Okay?
Ma'am,
Okay.
initially I was thinking, since the distance of P from AB is P from the same point on AB is the same as the distance from Q to the same point on AB, like perpendicular distance.
Repeat.
Sorry, I was just thinking that relative positions of P, A, and B and Q, A, and B are same, so that's why the circles must be same.
Kind of correct, but you will have to.
But that's not rigorous, is it?
Yeah, but kind of correct. But see, these concepts now, very good, Surya. Once you get this concept, then it is not difficult to give the rigorous proof.
Yeah, so like relative position naturally triangles.
What I suggest is you see such proofs you write as lemmas. Okay, in your proof you give this as a lemma, prove this separately, and then use this result to prove it. Huh? Okay.
Okay.
Followed. Yes. Coming back to original proof. Acha, sorry. Anybody here has any doubt? Everybody has understood this? What Surya meant? Huh? You want a screenshot of this? Or it's okay? Okay, ठीक है. Okay. Now this proof, everybody is ready for the proof, or you want some more time? Please comment. Should I give a hint?
You can give the solution.
Yes, ma'am. Done.
Okay. Okay. See, okay. So done. Surya, what is your solution?
Ma'am, so orthocenter reflection property I'm applying in HBC. So A gets reflected onto circle BH A prime. And AD equals D. What should be the image of A? A naught, A1, I guess. Image of A, let it be A1 onto circle A prime.
See, for this, proving for this, you don't require that, because you are reflecting it, right? So you can well reflect the triangle.
I wanted to show that circle, the circumcircle of ABC is same as.
Yes, for that, beta, consider this triangle and reflect it here. I will reflect entire ABC here.
Okay, okay. Oh, right.
Right?
Right. Sorry, ma'am.
Just reflect it.
Right.
So what will happen? I know reflection of H goes here, D1, correct? Okay.
Okay, ma'am.
Followed. So may I erase this?
Okay, ma'am. So then we get circles are congruent.
Yes.
And same thing for the other two circles.
Yes. So consider reflection of triangle ABC in side BC. So A dash B, so let A goes to A dash and H goes to D dash. And H goes.
No, let A go to something else, right? Because it's already A dash.
Achha, you have already A dash. So A goes to A1.
Yes, ma'am.
A goes to A1 and H goes to D dash. Okay? Followed? Therefore, we know that HD is congruent to this, correct? So, triangle HBC is congruent to triangle T1BC. Correct? Therefore, circumcircle of triangle HBC will be congruent to circumcircle of triangle T1BC. Followed?
Okay.
So this is as good as a reflection of circumcircle of A.
Okay.
Followed? Huh?
Okay, ma'am. So now then.
This is actually circumcircle of Sorry.
No, this is HBC and D1BC is for the other circle.
1BC is circumcircle of ABC.
Yeah.
Okay. So this is circumcircle of A1BC, which is also circumcircle of HBD. Correct? Okay. Can you see that?
And you're saying from the triangles you're getting that the circles are congruent by what you said previously.
Because they are circumcircles of congruent triangles, so they have to be congruent because of sides and angles property. Okay.
Okay. And then so then after that I want to prove that A dash lies on ABC.
A dash lies on
the circumcircle of ABC.
Achha, you are proving A dash lies on circumcircle of ABC.
No, but do we need to do that? No. 1 second.
I'm asking you what you did. I don't know.
Circumcircles, yeah, so they're all congruent. So now basically what I want to do in the end is I want to apply homotherapy through the circumcircle of ABC with of -1.
Circumcenter of ABC. Okay.
Sorry, circumcenter of ABC. And with ratio -1, and I want to show that it goes to A dash B dash C dash. So then all the lines will be congruent.
एक second. Homotherapy with center O. Let O be the circumcenter of ABC. Let O be the circumcenter of triangle ABC. Okay. Then A dash is nothing but reflection of O.
Oh, right.
Okay. In line BC. Can you see that? So, okay. Is it clear to everybody? A dash will be reflection of O. Then A dash is reflection of O in line BC. हाँ, अभी क्या करना है आपको?
Because radius is same, right?
हाँ, because yeah.
Okay, ma'am. So then.
Because not because radius is same. Because I have reflected triangle ABC to get this circle.
Oh, right. Sorry.
So reflection of circumcircle. हाँ, बोलो.
Okay, and then so what I want to do is show that homotherapy through O with ratio -1 will take A to A dash, B to B dash, and C to C dash.
How? A to A dash नहीं, A का
It won't be possible, right? Okay, sorry. I was thinking something else.
नहीं, A, that is not an antipode.
Right.
Homotherapy, this will go to antipode.
Antipode. Right. I was trying to get antipode, but I wasn't getting. So I guess that's.
ये नहीं work होगा. हाँ? Okay.
Right.
ठीक है. ये.
But can we still use this?
नहीं.
Okay, so only 2 was.
We will use this fact. We will use this fact definitely. But एक सेकंड, क्योंकि मुझे मेरा प्रूफ रिकलेक्ट करने दो, अभी मैं भूल गई होगी मेरा प्रूफ. हाँ ठीक है. So everybody understood till here A dash? Huh? Okay. Now
A dash, B dash, C dash is equilateral. Can we use that?
wait. Let me recollect my proof. Can I take a screenshot and erase this because I need to write again? Everybody has understood this much? Huh? Please comment. Huh?
Yes.
Now. So now just a minute. Huh. What I need to do is, you can see that there is no single homotheity I can use to transform these, correct? Okay. So I need to use a combination of homothetics, right? Okay. So what I'll do is, just a moment, to shift this toolbar first. Okay. So I will use a combination of homotheties. First homothety is O. See, you can see that midpoint of this. Okay. My O is taking homothety about O with ratio 2 is taking my midpoint of BC to point A dash. Correct? Huh? This is one homothety. Huh? Okay. Now, so I want to take a homothety that will take my A to midpoint of BC. Do I know a homothety that will take A to midpoint of BC? And then B should go to midpoint of AC.
So centroid with ratio
Yes,
2:1.
good.
2:1. Right, 2.
C to midpoint of AB, correct? So I need the homothety through centroid with ratio क्या होगा? एक सेकंड ना, मुझे क्या चाहिए पहले तो? I want A to midpoint ना? A to midpoint means what?
Minus half.
minus half.
Correct. We'll take A to midpoint of BC. तो मुझे क्या करना है अभी? Combinations of these two homotheties. So homothety through centroid with ratio minus half, followed by homothety to homothety with center O with ratio 2. Okay, this will take A to A dash, and similarly B to B dash, C to C dash. Can you see that? So this homothety will take triangle ABC to medial triangle, and this homothety will take triangle medial triangle to triangle A dash B dash C dash, correct? Okay, so this homothety will take triangle ABC to triangle A dash B dash C dash. Okay, followed? So we get that even circumcenter of A dash B dash C dash, what can we say about it? It will be congruent to circle
Of ABC.
Because see, here ratio of this conjugation of homotheties, what will be the ratio? Ratio will be -1, and suppose center is X. Now we need to figure out where the center will lie. Where the center will lie? Center will lie on Euler line, which is OG. Okay? Circumcenter and centroid. So center will lie on Euler line. Okay? Correct? Is it clear? The point of concurrency, point of concurrences will lie on the Euler line.
Yes, ma'am.
So again, so idea is that we take use a single homotherty to take all those points to the
yes,
A dash B dash.
whenever we want to prove something concurrent, we can think of homotheties. Followed? Okay. And when you get a part of it, then use that part. Okay. It's maths is all about what you want. Try to create that. See, sometimes you are successful, sometimes you are not. Correct? But this is how you should try to do it. Understood, beta? So you were halfway through. Very good. Well done. Surya, right?
Yes, ma'am. Thank you, ma'am.
Very good, Surya. But you understood how to. But Surya, I suppose you have very good ideas, but you don't know many basics, right, beta?
Yes, ma'am. This is my first year.
Yeah, this is your first year. Okay. You're attending juniors also?
No, ma'am.
This is very boring, junior. I can understand. Okay.
And now stop watching the lectures also.
Ma'am, it's a chaos.
I know. I can't help. It's a babysitting, you know. A whole week, I'm not tense, but in junior lecture, I'm so tense. What to do? Okay, so, you people remind me. I will share the worksheet. Okay, booklets in forms of worksheet. Okay, my booklet, PACE booklets. I can't share it to all. So please don't circulate it. This is off the record. I'm sharing it for you people. But how can I share it?
Ma'am, it should be on Panisha.
Yeah, they are on Panisha. If you can take it from Panisha, that's great. Just at least Surya and those who are fresh, please go through geometry session. See, I don't want you to lose any property. Read geometry booklets, and if you don't understand, please ask.
Ma'am, the booklet which you gave us last year?
Yes, Adish, same booklets.
Okay.
Same booklets.
Ma'am, and do you know when the hard copies will be coming?
That is very difficult to say because of Corona. Actually, we were about to give it for printing, but because of Corona, everything is stopped. So hard copies are not even printed, beta.
Okay, ma'am.
So after lockdown only, we can say. That's the problem. But it's okay. What we can. And I'll share one book, okay, where the theory is excellent. The Euclidean geometry theory is excellent. There are two books. One which is Challenges and Thrills, okay, and second book is EGMO, okay, by Ivan Chan. Okay, one is by Dr. Ranganathan. So I'll share.
Will you share it on group?
I'll share it on the group. And here you do theory. Okay. Don't do questions because challenges and three questions are very old type questions. Beta? And see, remember, you don't have to. You have to focus on the theory which is there in the booklet. Followed, which is important. See, in any subject there will be too much of depth of theory. Maths is like nothing is discarded up till now. So theories keep on adding and adding and adding, right? But we have to be focused and choosy about whatever is important for Olympiad. Okay.
Okay, ma'am.
Okay.
And what is the full form of C and TH?
Challenges and thrills. I'll just share it right away, beta. Don't worry. After the lecture.
Ma'am, I had a question about trigonometry, the functions. So usually, is there any so usually the functions they give values that are not algebraic, right? Like for most x, like for most inputs, the values will not be algebraic, right?
Irrational, yeah. You want
no, not algebraic also, not just irrational.
Not algebraic. They are algebraic. What do you mean by algebraic? What is the definition?
Expressed as like as a root of a polynomial
Huh.
with integer coefficients.
Yeah, so like for example, root 3.
For sine, for trig functions, the values that they give.
Oh, you can create, obviously. They are
No, ma'am, we get, so is there any pattern, like there is a, for example, there is a pattern. So I came across one pattern for, in which trig functions give rational values, and those are only the standard angles. There was a shrinking proof for it. And so I was wondering if there's any pattern for when they give algebraic and transcendental values.
Can you, I mean, I'm not understanding.
Okay, ma'am.
Like, I'm not sure whether algebraic, what do you mean by algebraic numbers?
Root of any polynomial, right? With integer coefficients. That's the definition, right?
Numbers that can be expressed as the root of polynomial with integer coefficients.
Yes.
So for example, root 3 by 2. Okay. See, so if I take x square is equal to 3 by 4, okay, or 4x square minus 3 is 0, I'll get this root, which is algebraic number. Are you talking about values of 30 and values of
no, I just so I'll just tell you. So sometimes you get rational values also.
Correct. Some values are like under root.
Some values are rational also, right? Like half and so on.
Yeah.
Half, 1 and all, 0. So and there's actually like a pattern for it.
What pattern?
There is a pattern where at least one trig function gives you a rational value for all the standard angles that we learn. So 0, 30, 45, 60 and so on, 90 and so on. And there's actually a proof for it. It's been proved that there is a pattern for rational values. That only for standard angles it happens, that you get rational values in any one function. So I was just wondering if there's a pattern for algebraic values, or is it just the fact that there are more non-algebraic than algebraic, so that's why they come rarely.
I have never thought about this, so I just can't.
Okay.
I'll have to. But what pattern you have for rational values? What are you?
Standard angles like 0, 30, 45, 60, 90, all the ones that we learn actually. At least one function will have rational value.
Achha, okay, so you are saying that for each of these, at least one of the 6 trigonometric functions will have rational values.
Yes, ma'am. And there's a nice visual shrinking proof for it.
What?
I don't remember the whole proof, but I just know that it's there.
Achha, you found it on internet or something?
Yes, ma'am. It was just completely visual.
Achha.
And I don't know how rigorous it is, but yeah, it's satisfied me. But yeah, so if you look at it, the pattern seems to hold. I was just wondering about algebraic values because I looked it up, and apparently they're transcendental functions. So most values they give are non-algebraic.
So basically you are saying about one function between sine, cos and tan has to be rational.
For these values, yes.
One second. So that is as good as saying that for these values. Yes. So your one angle is 90 degree, right?
Yes, ma'am.
Achha, okay. ठीक है. फिर next what?
So I just thought if there was a general pattern for algebraic, because it's just like the next step up, I thought.
I'm never going into
so I mean there are like two explanations. Either there is a pattern that I could come up with. Either there is a pattern, I just don't know what it is. It could be there. Yeah. Or it's just the fact that there are more transcendental numbers than algebraic numbers. So that's why they're algebraic functions. So between 0 and 1, you'll just, the probability of finding one is more than the other. That's it.
can't comment on this. Really, these things are never obvious.
Yeah.
These things are never obvious. They have to have rigorous proof to even comment on anything.
Yes.
And I have never ever thought on these lines because see basically how theories are developed, Surya. Now you are working on this, suppose, and you find some results, and that results are useful in proving some unsolved problems, previously unsolved problems, or even previously solved problems. You get some nice proofs from that. So such a result then are incorporated in the theories, and that result you have to check whether it is not contradicting any previously existing theories. This is how the theories are developed. Okay, followed? And so it's a very long process. But it's not that nowadays anybody thinks of anything, they put it on the internet. But it should not be like that. Okay, I mean, yes, you have to prove it as a heuristic, or you have to prove it as a, what do you mean by heuristic? Or it can be claim. You cannot claim. You have to suggest it.
Intuition just says that.
Like for example, Fermat's last theorem was suggested,
right.
Or four-color problem. It was a suggestion that I feel like this, but I don't have a rigorous conjecture. I don't have a rigorous proof. Achha, you know the word conjecture. Okay, it should be a conjecture. What do you mean by conjecture? I feel this, but I don't have a rigorous proof. And then different mathematicians will also work on it, and somebody will come up with rigorous proof. Then that is added into theory. Okay, this is how theories are developed. Huh? Okay, so even if you get a rigorous proof, if it is not very useful theorem, okay, its spectra is not sufficient, then we don't put it in the theory. Okay, or okay, that result will stay in the theory, but after a while that will be forgotten because that is not so useful result. Okay, followed? Huh?
Yes. Okay, thank you.
But definitely it's worth working on it, Surya, because you never know when your theory can be used in wherever. See, it is a saying, that mathematicians, like pure maths people, are very proud that they work on pure maths for sake of research. They do research because most of the maths is applications. Okay, so pure maths people feel that we are great, and they feel that applied maths is not that good maths, because applied maths is usually a branch of maths which is developed for helping some other branch of knowledge. Are you getting me? Okay.
Yes.
But ironically,
it's like in science, chemists say biology is applied chemistry, and then physicists say that
it's
chemistry is just applied physics. It's scale of purity, right?
Like derivatives was first developed, okay, for helping physics, for supporting physics concepts.
Yes, ma'am. So that's what I'm saying. Purity scale. So maths is all the way up there.
So, but irony is, you prove a result in pure maths, and after few years, you will find its application in some branch of knowledge. Like for example, I'll give you a familiar example. Graph theory was initially a pure branch of mathematics when Euler discovered it. Correct?
The bridges, right? The bridges of
yeah. Now you have many applications, like graph theory has almost application, they say, in almost every branch of knowledge.
Yeah, social networking and things like that.
Yeah, like I heard that underwater, what do you call them? Marine, that underwater ships.
Submarine.
They also use some graph theory to send some signals and all that. God knows what. Okay, it was beyond my reach of understanding what exactly. They have not mentioned exactly what maths it was. But yes, in computer networking and all that, you need graph theory. So Combi is a hot cake. Okay, you should.
Is graph theory useful for our RMO?
Of course, today is an era of graph theory. Now you use graph theory to solve almost every alternate combinatorics problem. I'm going to teach you rigorous graph theory. That is, what do you think we do in super advanced batch? Half of the time we do. Okay. Graph theory is most important today. Okay, half of the problem in IMO Combi, you check, they will be using graph theory. Okay. So good, keep doing it. You may find it useful or you may not find it useful in a short time, Surya. But at least it will give you some brain development. That is also not less.
Oh yeah, ma'am. And also one more thing. I think I'm sorry. I didn't state the thing properly. Obviously, there are infinitely many rational values since it's continuous from -1 to 1. But for factors of pi, like rational factors of pi, like pi by 2, pi by 6, and so on, pi by divided by something, then these are the only values. Sorry.
Okay. Yeah, that is there because it's a continuous graph.
Right, continuous from -1 to 1, so there'll be obviously be infinitely many.
-1 to 1, correct? Okay, it's
right.
a continuous
The
graph.
pattern here is that for pi by some integer.
But for particular theta, there has to be at least one. This can't be a rigorous proof for that. This
Yes, ma'am. Not for particular theta, but yeah, the pattern is that for pi by some integer, then you have to, then only these values work. So
pi by some integer n. Then
yeah,
you,
I think
at
so.
least one of this thing is rational.
Then for not for any pi by n. Out of pi by n, these standard values that we are looking at, the ones that were taught usually, those at least one is rational.
Okay. So you want to say for pi by n is equal to 6 or 4?
I guess so. 60 and so on also.
Yeah. 2, 3, 6, 4. Yeah. These standard.
And then repeating after 90, just repeats.
Why you need proof? You have all values. If you are just focusing.
No, but how can you say that for any other n it won't be rational?
No. My question is, do you know for only these many n's, or you have some other this thing for n?
No, there is a proof that only these n's work.
Only these n works.
Yes, ma'am.
Acha. Okay. Acha. Now I understood what you wanted to say.
Sorry, my statement was incomplete. Even I was wondering if I can make that argument for algebraic numbers. Why can't I make it for this one?
Yeah. It's okay.
This statement was
okay. I wanted to talk about this, that many a times whatever you want to say, you are not able to put the statement properly. And especially on this, the other day Arkan has wonderful proof. I don't remember which class Arkan, number theory or combi.
He is not there.
Achha, I was very upset about that, and I want to train you how to write the proofs. Okay? Okay. So is it okay we conclude here?
Yes, miss.
Thank you, ma'am.
All the best.
Thank you, teacher.
Welcome. Anybody has any doubt?